All right, let's get going. A relationship between sine and cosine that you have not realized yet. Let's do this real quick. I want to find the value of sine A using my right triangle. You're not, guys, you're not solving for anything. You're not cross multiplying. I would just like you to take x, y, and z and tell me what the ratio is for sine of A. So sine of A, what is the ratio using my right triangle with sides x, y, and z? That's all I need on that one. So what is the ratio? Then I got a challenge for you after you tell me that. All right, so what is my ratio here? Number one. There we go. Y over z. Everyone all right with that? All right, here's your challenge now. Find me another one that also has a ratio of y over z. Find me another ratio that comes out to be y over z. Maybe a different angle you want to use. It's up to you. But find me another one that you could say this is also equal to y over z. Find another one. Sine, cosine, tangent, different angle. Find another one that also comes out to be y over z. All right, what else comes out to be y over z? Oh, you're up 15. Cosine of what? B? Okay, well, first, what's B? It's a right angle. Can never go from a right angle, right? You're on the track with the cosine. What's y adjacent to? Which angle? Other than your right angle, which we can't use. That adjacent to what angle? Angle C. So if you do cosine of C, that'll also be equal to y over z. We good, Cece? Okay, everyone else all right? Those two are equal. So here's what you guys just told me, that the sine of A in this problem is equal to cosine C. Next part to dig a little deeper. And you can tell me anything. What do you know about those two angles in the triangle? I'm looking for something specific, but I'll take anything you got for me. What do you know about A and C? Aman? Are they complementary? Do they add to 90? Yeah, that's the one I was looking for. What's so special about them? They are complementary. So here we go. Here's the conclusion we're going to work on today. If A and C are complementary, angle A, I'm going to put angle A and angle C. Then the sine of one angle will be equal to the cosine of the other angle. But they have to be complementary. All right, this is only true. I can only write this if A and C add to 90. And then I could also do this too. The sine of C would be equal to what? Cosine of A. And I think this is pretty neat, so I'm going to show you. What's the topic near day 11 right there? Cofunctions. How do you say that? How do we say that? One more time, kids. How do you say that one? How do you say it? Cosine. Sine and cosine are what we call cofunctions. Okay, they have a relationship. And what's the relationship? When they're equal, their angles add to. Okay, well, let me do that again. It wasn't the reaction I expected. When sine and cosine, if sine and cosine are going to be equal to each other, their angles have to add to 90. Let's see if we actually understand that now. All right, I got cosine of 20. I want something else that's equal to the value of cosine of 20. So everyone in your calculator right now, if you have it out, cosine of 20. That's what I get. I want something, another degree measure with sine, cosine, or tangent that also comes out to be 0.93969, da 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 da. All right. What's cosine a cofunction with? Sine. And if sine and cosine are going to be equal, their angles better add to 90. So what's our guess before we check it? All right, let's see. Let's go back. Boom. We could do this all day long. All right. Dylan, give me an acute angle. 50. Cosine of 50. Guess what it's going to be equal to? Sine of, not 50. 50, come on, Mike. You just blew it. Sine of. Do this all day long. Yeah, we are. Naomi, give me another acute angle. You want to do sine or cosine? That should be equal to what? Cosine of, uh-oh. There you go. Okay, go ahead, go to number 2. Sine of 37. Should be the same value as. Don't just give me the angle either. Here you go, 9, same value as. One job. How about 10? Don't care. Okay, everyone good with that's pretty easy, right? All right, well, let's keep going here. Where else could I use this relationship? I got x and x plus 20. Those are 2 acute angles. And look what I'm writing right here. Sine of x is equal to cosine of x plus 20. What's x have to be? Well, hey, this is only true if you know what about your 2 angles. This is only true if I know what? 53 and 37, 20 and 70. Okay, so what equation can I set up right now to solve for x? Because it's not this. I'm not setting them equal. When are sine and cosine equal to each other? Only if. What do I want to put in between them? When they add to 90 degrees. Okay? If I see sine and cosine equal to each other, right away I'm thinking, oh, their angles must add to 90 then. Woo! Good. So x was equal to, and I'm not asking you to, but if you plugged in 35 for x, you would see those add up to 90. Questions? Dig deeper now. All right, so I have this triangle ABC. C is the right angle. So if C is the right angle, just to get a visual of this, what do you got to know about A and B then, if C is already the right angle? They're complementary. They already add to 90. So if the cosine of A is radical 21 over 5, what's got to be the sine of B then? Whoa, 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 whoa. What's the relationship between these two? We've already established A and B are complementary. They add to 90. So what's the relationship between these two? They're equal. So if one's radical 21 over 5, what's the other one? Oh, whoa, 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 whoa. Whoa, 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 whoa. Guy, look. Cosine of A is radical 21 over 5. So what's got to be the sine of B? They're equal. They're always equal, right? I don't know why we're playing around in the calculator. They're equal. Yes, everyone good? If A and B add up to 90, we all agree A and B add up to 90? So the cosine of one equals the sine of the other. Good? All right, I know one's definitely not making us great on this part. Here we go, 5. Another right triangle where C is the right angle. Okay, hey guys, what do you know about A and B? Complementary, they add to 90. So that means the cosine of B has to be equal to what other function? Sine of A, yeah. Which function also equals 5/13? Got to be sine of A. All right, how many people am I going to catch on this next one? I got a right triangle. The sine of 40 minus x equals cosine of 3x. What's x? They are telling you sine and cosine are equal. In your mind, when's the only time that happens? In a right triangle, when's the only time sine and cosine are equal? If, what are complementary? The angles. What are my angles here? Not if they're equal. If they are, add up to 90. That's the only time that statement up there is going to be true, is if those angles add to 90. And I know you're in honors, and I would really prefer that you never, ever did this, but this is multiple choice, correct? Worst comes to worst, take 10, plug it in, go to your calculator. Do they equal each other? Okay? Desperate times call for desperate measures, so if that happened, you can do that as well. Talk about this one with people around you here. I'm interested to see what you're going to do here. Okay? Give you about a minute here. Think about the relationship. Think about the relationship. I'm not asking about the angles. I'm asking about the cosine of angle B. I'm not asking about the actual angles. Yes, it is. Yeah, it is. Welcome to honors. What's your question? Were you in honors last year? Some of you guys, I don't know how, but yeah, you were. Too harsh? Too harsh? All right, here we go. First step. What do you know about angles A and B? They're complementary. So we're asked about these two. What do you know about them if A and B are complementary? So as this value, not the angle, I think some of you guys were focused on the angle. As this value goes up, they have to be equal to each other, guys. They always have to be equal. So what's got to be happening to cosine B? It also has to do the same thing to be equal. So cosine B will increase Because sine of A is always equal to cosine of B. Okay? Got your laptop, got your Chromebooks on you. Let's get them out, open up to Aspen, get the answer key for the homework out so you know you're doing these correctly. Yes, one of them, one or two, I can't remember, will be on the quiz tomorrow, cofunctions. Nothing different than what's on your homework though. All right, nothing different than what you're about to do. And, and there's review problems too. Take it seriously, all right? Yes?